Hello everyone, Krishna on this side. So in this video, I'll be covering this LeetCode problem 3440, reschedule meetings for maximum free time 2. Okay, I'm not reading the problem statement. You can pause the screen and go through the problem statement. I'll explain you anyway directly on the screen. So these are the examples that are being given to us. Okay, and talking about the constraint, these are the constraints. Okay, now let me directly take you on to the screen and explain you the problem. What is the ask? That is something what we will try to see. So the first thing is like it has been given a start time, end time array, and there is a event time variable. It is having a value. Okay. So all these basically events that we have, right? Their start time and end time. All these events are occurring in a range from 0 to this event time. Okay. So the first event basically took place between 1 and 2 time. Okay. In this range, it has been occurred. So yes, that is something how it basically looks. Let us name it as Q1. Second event is basically its start time is 3 and end time is 4. So it is occurred at this particular location on the particular this timeline. Third is like between 6 to 8 it occurred. Next one is like between 9 to 12 this event got occurred, and last one is like between 12 to 13 the last event got occurred. Okay, so if we simply represent them on this particular timeline, these events basically look kind of like this. Now the question is we have to find the longest continuous period of free time. Okay, so here the continuous period, it is free time, right? Currently in between this 0 to 1 unit of time, no events occurred. Between 2 to 3 also no events occurred. 4 to 6 no event. Between 8 to 9 there is also no event, and 13 to 15 there is also no event. So these are like continuous period of time that we have. These are free times, right? So no events are basically taken place in between these times. Yes, these are free times. Okay, so we have to figure out the longest continuous period of free time, and there is another constraint. Okay, so what we can do is we can at most shift one particular event or reschedule this particular event, okay, in a such a way that if its value, whatever this first event, let us suppose this first event has been there, this first event, I am allowed to reschedule this event. Okay, I can reschedule it at any point in time on this particular range if at all this event is getting uh, I mean it is been able to fit into that particular time range. Okay, so what we can do is like let us suppose this first event is basically having 1 unit of time, so we will try to figure out where this 1 unit of time can be fixed, right? If it is able to feasible to put this particular event in the particular duration or not, that is something what we will try to figure out. That way what happens is if we try to reschedule this event, okay, if we try to reschedule this event, this particular time duration 1 and 2 will get free. Okay, and once if it is getting free, this range from 0 to 3 is again free, because in this particular area and this area it is already free, right? No events are being there. So yes, in total like we get a long range, right? Previously range was like 1 unit in both the side, but now when we reschedule this and try to place it at any other places, okay, here also this particular event easily it will fit, because its range is only 1, and if I can place it between 8 to 9 it can easily fit. And of course we have to make sure that this whatever the events we are rescheduling, it shouldn't be getting overlapped with any other events. Okay, that is something what we have to make sure. So, Q1 can be placed in all the different locations. Okay, Q1 can be placed in all different locations, and once if we remove this Q1 from this particular timeline, the longest range is basically 3. From this one, when we try to shift this Q1, we get 3 as an answer, longest range. Okay, the same operation we can try it out for Q2. Okay, at most one particular event we can reschedule, and we have to get the longest continuous period. Okay, so that way we can try out for all the different events. Like for Q2, Q2 is basically available in this particular range, right? From here to here, Q2 is available. I just have to make sure that this Q2 should get out of this particular range. Okay. And is there any vacant places where I can keep this Q2 event, right? So I can either take this Q2 and try to put right over here. There is one possibility, or here there is another possibility. In this range also we can place this Q2 at any point in time. If it is possible to move this Q2 out of this particular range, the answer is pretty much like we are going to get this long range, right? because this is now a complete free time period that we have. And initially it was like having from 2 to 3 there was a vacant time period, and from 4 to 6 there was another one. But now once we remove the Q2, there are no events occurred in this particular time range. So yes, the range is like from 2 to 6. The answer is something of we will get 4. 4 is the answer, new answer that we got once if this Q2 was successfully removed from this particular location, correct? So yes, with the Q2 also we are getting a better answer compared with the previous when we are trying to shift this Q1. Okay, so there are possibilities, further possibilities, like if we are trying to do with Q2, there are again like for Q5 or Q4 or Q3 also, if we try to move them out from their range, it could possibly give us the best answer, and we can perform only once this operation. So we will try to do this removing this particular event during their timeline, and we'll try to get if try to see if it is giving the best answer. So for Q3 again, it is like having this range. Okay, this is the range. In this particular range Q3 is available. So best answer I'll get is if I try to remove this Q3 and try to place in this right side or in this left side. Okay, and also we have to make sure that this Q3, wherever we are placing it, it should be feasible, it should fit in that particular area. Okay, that is something what we have to take care of. Okay, now again for Q3, like we will see in the left side, maximum range that we are getting is like 1. Okay, here like this is vacant place, this is free, another free place. In these areas only we can place any particular events, right? So if we try to shift this Q3 in left side, there are no chances because Q3's range is basically 2, and two timelines. I mean, we don't have any time period here in this particular range which has two vacant places simultaneously at same point in time. This Q3 cannot be placed in left side. What if we try to place Q3 right over here? Is it possible? Yes, it is possible because this completely from 13 to 15, no elements, no events that are been taking places. So yes, we can easily move this Q3 in that particular region. Okay, now this Q3 is also possible. So if we remove this Q3, if we able to remove this Q3, right, what is the answer that we can get it? So here whatever this gap plus this Q3's range. Okay, it's start time and end time we have already. So end minus start. Okay, plus whatever this gap that we have, like let us suppose it's gap 1 and this is like gap 2. If we add them, we are going to get the answer, correct? So yes, again from Q3 also, if it is possible to move this Q3 out from this particular range, and we can get the answer, and the total answer that we can get is like 9 minus 4. That is the entire range that we have. 5 is the answer that we are getting. Now with Q2 we were getting answer as 4, with Q1 we were getting answer as 3, with Q3 we are getting 5 as an answer. Okay, so now it is giving us a better answer, right? So far with Q3 we got the best answer. Okay, so the answer is something what we will keep on maintaining, where this answer is we will keep on updating. If at any point in time when we move this particular event from the given range, we will just have to check that whether it is basically giving the best answer or not, what with previous answers, right? That is something what we have done. Now Q3 is also done. Next is like Q4. Okay, that is the event that we have. Q4's range is like this. Okay, in this range only Q4 is available. Is it possible to place this Q4 in right side? Because here the range is basically 2 and Q4's range is basically 3. From 9 to 12 it is basically occurring, right? Between 9 and 12 it is this event basically took place. So what we can do is we'll try to see if it is possible to place this Q4 in the left right side. It is not possible. Is it possible to place this Q4 in the left side? Here the range is 2, here the range is 1, here the range is 1. These are all the free gaps that we have. In these gaps only we can place any elements or any events. Of course, it is not possible to place Q4 in these areas as well, because the maximum gap that we got from this range was 2. Maximum gap that we got in this range was 2. Okay, so yes, it is not possible to place this Q4 in either of the side. So if it is not possible, now the formula will get changed. Okay, previously the answer was 5. That is something what we got. Now the formula will get definitely changed, because we cannot, if we cannot move this particular one in any of the areas, simply whatever the gap that we have, let us suppose this was the gap 1, and Q4 can be replaced in this area or in this area. Okay, either of the, at whatever it is available current place, there it can be placed as it is. So answer is basically this 8 minus 9, whatever the gap that we are getting, that is the answer that we can get it, because Q4 cannot be shift in any other locations. So from, even if we are not able to shift this Q4, from there also we might get answer, maximum answer. Okay, there could be a chance. So yes, of course we will keep on calculating this answer, whatever answer. So from here the answer is basically 1, because Q4 cannot be shifted. So this range cannot be considered in our answer. So answer is like whatever the gaps that we have in this particular range, that is something what we have to consider. Okay. So yes, from Q4 we got the answer as 1, and previous answer was actually better. 5 is the answer that we got it after removing this Q3. So yes, we are okay with that. Now Q5, again we will try to shift this Q5. Q5's range is like this. Okay. If we try to place this Q5 right over here, it is possible we can place this. So at any point in time, if we understood that if it is possible to place this element in other locations, either in the left side or in the right side, we can easily calculate the range. The range is like this gap and this Q5's range. Okay, that is the answer. So here the answer is basically 3. Previously we got best answer as 5, so that is going to be there. So the best answer that we got is like removing Q3 and allocating it in other time frame. We can easily get the longest continuous period of free time. Okay, that should be clear. Now the idea is clear, and few of the concepts are also clear, like we are basically relying on the gaps, correct? So if I want to calculate this answer, right, in this area, we are simply traversing it. For Q1 we tried, for Q2 we tried, for Q3 we tried, right? So simply we are traversing into this array that we have given, start and end time, based on this. The only thing is like we need to know what are these gaps values, right? So that is something what we will find first. Okay, what are the gaps values that we have? First thing that we are trying to fill is like we will create a gap array. In the gap array, all the gaps, whatever the gaps that we have between the events or between the different time frames, we will simply calculate them. Because for Q1, this is the range that we have. So this is like gap 1 and this is gap 2. If I am able to move out this Q1 in from this particular range, the answer is easily gap 1 plus gap 2 plus this Q1's range. That can be get it like end time minus start time. Okay, end time minus start time. Okay, this way we can get it. And same thing applies for Q2 as well. Now Q2, for Q2 again, like it is like this is the range. Okay, this is the range. This gap we already figured out. Okay, that way only we can get it, right? Like I don't want to recompute this whatever the gap that we have. We have to make sure that these gaps, this is like first gap, second gap, third gap, it is like fourth gap, then it is like fifth gap. All these gaps, it is again, here is also another gap, it is basically 0 gap between Q4 and Q5, that is also necessary. Yes, we have to make sure to collect all the different gaps that we have. And last one is like whatever this gap that is there, that is also we have to figure out. Okay, so in total all the different gaps value is something what we will try to figure out by simply subtracting from the end time and start time of the next event. Okay, so gap between 0 and 1 is 1. Okay, so gap is like here it is 1. 1 is something we got, here it is 1. 1 is something what we got, here it is 2. 2 is something we got, here it is 1 again. And at last here it is 0. Gap between Q4 and Q5, the same thing we are applying, we are simply traversing and we are getting the gaps. And lastly Q5 to event time, in between also there is a gap. So also this gap is like basically Q5 to this one, it is 2. Okay, these are the different gaps we got. Okay, now gap array is something we got. So now it is pretty much easy. For Q1, all I need to know is whether it is possible to shift this Q to Q1 from this particular location to any other locations. Okay, for Q1, I just need to know is like whether it is possible to shift this Q1 from this particular range in other areas, either in the right side or either in the left side. In both the directions, we will try to see if Q1 is possible to move out from this particular location. If it is possible, from the gap array, whatever the 0 index gap, first index gap, we will simply add it with this one, range of this Q1. If it is not possible, the answer is like gap 1 plus gap 2. Only two things we are doing it. If it is possible to move out this one, the answer is like gap 1 plus gap 2 plus this whatever the Q1's range. If it is not possible, gap 1 plus gap 2. That is the answer that we are going to have, because Q1 can be placed in the same range only. Wherever we can place it, either of the side we can place it, either in the left side or on the right side. The gap is whatever the remaining gaps that we have, that is the answer that we are going to get. Okay, so yes, the simple thing is like if it is possible to remove, we will just add the range of that q1 as well. If it is not possible, we will make sure to just consider the gaps between this given range. So the gap array is something what we already calculated for first index, for the first q1, the answer is like this two. For the second q2, the answer is like this two, correct? For third q2, I mean these are the events, right? For the q3, the gap is like this, and this is the area, right? So this is gap and this gap, so it is like 2 and 1. Okay, that is the answer that we can get it. For q4, the answer is like between 1 and 2, 1 and 0, sorry. And for q5, the answer is like 0 and 2. Okay, these are the gaps that we have for each of these events, right? So that way we like simply from the gap array, we will consider 0 and first index for the first particular event. For second event, that is like q2, we will simply consider the second index and sorry, first and second index from the gaps array, whatever the gaps that we have. So simply for that, like we have collected all the gaps. Okay, now with the help of gaps, easily we can consider the answer and range also. But the question is like how to figure out, like, see, I cannot simply keep on going and traversing into the area and try to see like q1 is possible to place in the right side or in the left side. It is like we are just looping the same thing and we are increasing our complexity. We have to make sure that we will get the best, okay, from the right side. We will make sure to get the best uh, gap that we have. I mean the maximum gap that we have from the right side, maximum gap, okay, for each index. So there, like we will try to go through this gap array, whatever the gap array that we have, okay, and from there we will try to compute all the gaps that we can get it, okay, all the gaps we can get it from the right side, okay, from the right side. For q3, okay, for q3, let us just focus right over here. For q3, the best answer that I can get it from here or I can get it from here. In either places, if there is a chance that q3 can be placed, where can be q3 placed? If there is uh, uh, two size of spaces remain, two size of free spaces remain, then only q3 can be placed. So what we will try to do is, from this gap array we will again create another array. Let us say that the name of this array is like right max array, and there is another like left max array. Okay, from either of the side, whatever the array that we are having, from either of the side, for q3 we will just check that if from the left side this value at this particular index, if it is maximum, because currently we are at q3. So for q3 the values are like this is like for q1, this is q2, q3, these are index like 0 1 2 3. Okay, so we have to make sure that from 0 or 1, or from here it is like 4 and 5, which is the best place where we can place this q4 q3. Okay, that is something what we have to figure out. And we will not again keep on going in the backside and check whether we can place at this location, whether we can place at this location. So we will simply pre-compute the values. Okay, the moment we are traversing in a forward, okay, from the left side we are traversing in the forward direction. Okay, from here we are keep on going. So what we will do at the zeroth location, whatever the gap that is there, that is same that we will be having. Okay, one is the gap that we have, one is something what we have placed at this location between 2 to 3. The gap is 1, and previously the gap answer is also 1. So maximum is something what we will keep on updating. Maximum value is something what we will keep on updating, so that at any point in time when we are looking for q3, or when we are looking for q4, from the left array or from the right array, I will just look for the adjacent values. I will just look for the adjacent values. I don't want to keep on going in the back and see which is the best answer where I can place this Q3. If we, while traversing itself, we will, if we try to get the best answer so far possibly at that particular index, we will simply update it, so that it is pretty much easy to get these values from this array and check that whether q3 can be placed in the left side or right side at any point in time. If it is possible to place in the left side, we are okay. If not in the left side, we will check in the right side, in the right side's index, previous index, if it is possible to place this q3. If it is possible, we are okay. I mean from any of the side, if it is said okay, we will simply enter into that, and we will simply consider q3's range also in the gap array, the counting that we are doing it. Okay, I think the idea is pretty much clear. So let us try to compute this left tire max. For gap 0, 1 is the answer that we got. For gap 1, 1 is again we got. Now at the second gap, 2 is the answer that we have, right? At this location, 2 is the answer that we have between 4 to 6. Okay. So simply new answer is something what we will update, that is 2 in the left max. Now next is like between 8 and 9, there is a gap that is 1. but from backside we have noticed that 2 is the best answer that we got. So simply instead of updating with 1, we will update it with 2. Okay, now between q4 and q5 gap is 0. Okay, between q4 and q5 gap is 0, but there is, from the previous side, we have a place where we can place any element of size 2. Okay, so simply I'll update with 2 instead of updating it with 0. Okay, at this location. Now after q file, last is like whatever the last index that we have, for there also this 2 is the maximum, because there also 2 is the gap that we are having. Same thing that we will do it with the right max as well. Again, from the right max, we have to start from the end of the array. So from end of the array, we will keep on moving and keep on updating the maximum answer. So far we got it. Okay, for q1, let us suppose q1's length is like 3, and at last index only I have that range. So, and in between all these places, the gap is basically 1. All these places gap is basically 1. I don't want to go and keep on checking and looking if I can place this at this, in between this gap, in between this gap and all, right. Whatever the maximum answer that I have, I can easily place it at that location. So simply while traversing from the backwards, whatever the answer that I got maximum answer, that is something what I'll keep on updating in each of those locations. At any point in time, if I get another maximum answer, from there onwards I'll keep on updating that maximum value. Okay, the idea is pretty much clear. So same thing we will do. At last it is like 2. 2 is the maximum value we have. Again here 0 comes. So instead of 0, we will replace it with 2. 1 is something what we got. Again for 1, 2 is something what we will replace, because in the backside we have two size of array where we can, I mean two size of length where we can easily place if whatever the current value that we have, right? Okay, that is something what we will keep on updating. So this will get filled with 2, 2, 2, 2, 2 all the way. Okay, this array basically got filled with 2, 2, 2. Now this has been done. Now we have created ranges as well where we can place it. Now the only thing is, like, again we will iterate it. We will start with the q1 and we will try to see if it is possible to move this q1 out of it. So for q1, the formula is like gap of 0. Okay, gap of 0 plus gap array of 1. And if it is possible to move this q1, if it is possible to move this q1, the range of q1, that is like end time minus start time of q1. Okay, those are the things that we have. What we will do, we will simply check. See, in the left side we cannot check it, because q1's range is like from 0 to 1. In between this, I am not interested to check whether I can place this q1 or not. I am interested whether this less than this, if there are any indexes, or greater than this one, if there are any indexes where I can place it, because at this particular gap of 0 and gap of 1, q1 is basically already available at that location. Okay, q1 is already available in that location. In that range only q1 is available, right? So this is the range that we have. This is gap 1, gap 0, and gap 1 index. Gap 1 and gap 0. In this range, I am not interested to see whether I can place this q1 or not. Okay, q1 is already there. I just want to make sure that from this gap 2 onwards, whether there is any chance that I can place this q1 or not. Okay, and at that location, particularly gap at 2, 2 value is there. Okay, whatever the maximum, sorry, from the right side we have to check, right? So gap of 2, 2 is this is like from the right side we got, and from the left side we cannot go in the left side currently. So at right side 2 is the maximum answer that we have, and q1 can be easily fit if the range is having 2, because q1's range itself is 1. Okay, so we can easily move this q1 in right side of this one. Okay, so if it is possible that q1's range also, we will add it. If it is not possible, that q1's range we will not consider at that location. So same goes with q2. Again, q2 is like gap 1 and gap 2. I am not bothering at all. Okay, gap 1 and gap 2, I am not interested to place q2 in the gap 1 and gap 2, because q2 is actually available in that particular range. Okay, q2 can be shifted right side as well as left side. There is no doubt at all. Okay, so I'm not interested to update this q2 in the gap 1 and gap 2. I'm interested to see whether I can place this one at gap of 0 or gap of 3. Okay, simple for loop we are running. For the q2, it was like from 2 onwards we are checking. For q3, it is like from 3 onwards we are checking whether I can place it in the right max index of third index. Okay, and for the left side will be activated now, because at gap of 0 also we can place this q2. Okay, for the first index q1, I am not having place to replace this q1 into gap 0, because that is where q1 is basically relying. Yes, that is the formula, right? So we will simply keep on checking the right side as well as left side whether it is possible to place this whatever the current event or not. If it is possible either of the side, then we are done. We will simply calculate its range as well. Okay, I think it should be clear for now. Let me try to write down the code. It is pretty much easy. If you get the idea, you can easily write down the code, right? The first thing is like, let us try to create the counts. Okay, whatever the gap array that we have between these gaps, all the gaps values is something what we have to consider. So n equals to get the length, start time. Okay, start time dot length, we got the length. Now let us create a gap array. Okay, gap array will be having length of n plus 1 because if we are trying to shift any particular event, let us suppose q1, I am considering gap 0 as well as gap 1. Okay, and this will happen for last index as well. So obviously there is one extra space that is going to be there, this gaps between all this. If there are 5 events that we have, then there is like six gaps we will be going to have. Okay, so those 6 gaps is something what we have to consider. Okay, so that is the idea. Now let us try to fill this gap array. Int I equals to 1, because at gap 0, gap array of 0, we will simply fill it with uh, start time of 0, because start time minus 0 is something what we have to place it, right? Gap of 0, because if we notice the q1 was placed at 1 and 2, and for q1 the first gap is like 0 to 1, that is the gap. If at all this first start time itself starting from 0, no, doesn't matter, the value is basically equals to 0. Okay, so simply I can write it like start time of 0. Now this for loop we will run from the first index I less than this whatever the range that we have, it is like n I plus plus. Now we will simply update this gap array, right? So gap array of that particular index is basically equals to whatever the current event that we are having, current event start time of I minus previous index end time. That way we can easily get the gaps. Okay, previous events of end time. So this way we will get all the gaps between the events. And the last event is like if the last event, whatever the last event that we have at the end index, it is like whatever the event time that we have, event time minus end time of the last events, right? Whatever the last event that we have, end minus 1. Okay, that way we can update the last gap that we have, because q5 was like in the example it was occurred between 12 to 13, and we have event time as 15. Okay, so last whatever the gap that is there, that is also we have to consider. Okay, so yes, gap array is something what we have created. Now let us create a left array, left max. Okay, and its range is also same, like whatever the gaps that we are just trying to utilize them from the right side and left side, so that I don't want to recompute them again and again and go and check whether it is possible or not. We can easily with this creation of these arrays, we can easily get these values. Let us start with filling this left array. So at 0th index, whatever the 0 values been there, that is something what we will fill. We will go all the way to n in this left array of max, left max. Okay, left max of I, it is like whatever the maximum value you have, previous index value or this current index, whichever is the maximum gap array of I or previous index value. So left of max of I minus 1. Okay, so at the first index, let us try to fill this at left max of this 0. We'll simply fill the gap array of 0. Okay, because there is no way this will get any maximum value apart from the whatever the default value that we are at the gap array. Okay, now we have filled this again, we have to do same thing for the right. Let me just copy paste and utilize this right. So at right of last index n, whatever the gap of last index that we have, that is something what we will fill. I will start here from n minus 1. I should be greater than or equals to 0, and this I is basically minus minus. And here again, just let me copy this right array of here, it should be I plus 1, because whatever the next event that we have, from there only this right max value is getting filled. Okay, and here it is like gap of I, it should be fine. Okay, that way we will fill right array as well. Now once we have both the maximum minimum values, we will simply loop through it. from these events. So let us suppose we'll start from I equals to, let me just take event from what is that? Okay, I cannot take it event from, I have to run loop for I equals to 0, I less than n, I plus plus. Okay, at 0th location, let us try to get a event that is been occupied the space. Okay, so it occupied space is like, space is basically equals to, what is that, end time minus end time of I minus start time of I. So we got the occupied space from here. The moment we got this space, we will try to create answer here. Int answer equals to, or current answer equals to gap of 0. Okay, whatever the gap of I plus gap of I plus 1, correct? That way only we are getting the gaps. Whatever the gap for the first event, it is like 0, and first gap, whatever the gap that we have, that is something what we will consider. Now this occupied space we only consider if it is possible to shift this particular event either in a left side or in a right side of the given timeline, right? So we will simply check if, okay, if I is basically greater than 0, okay, that is the first condition, because at 0th index I cannot go in the left side. And from the left array, left of I minus 1, if that is actually greater than this occupied space, that means like I can simply move this, whatever this current event that we have, in the left side. If it is not possible in left side, I'll simply check in the right side. For the right side, it is like I should be I plus 2. Okay, it should be less than n, because that is something what we are doing it right over there, right? uh, 2 index is something what we are missing. 0 and 1 are basically allocated for q1, and now I have to look for from second index onwards. So I plus 2 is, it should be less than or equals to n. Okay, and this right of I, okay, right of whatever this I plus 2 that is there, it should be greater than this occupied space. Okay, because all the maximum values is something what we are getting it from this right side as well. So if either of the case that is correct, we simply can return the answer. Okay, so let me just place proper and of brackets. The first condition is like in the left side we are checking it, or second is like in the right side we are checking it. If at any point in time, if it is returning true, okay, we have a possibility to place there. Simply this current answer, it will get updated with this occupied space as well. Okay, let us just update this. We will add this range, whatever the range that we have. Okay, at the end we have to maintain another answer, that is something what we have to return at the end. So this answer will get updated with answer equals to mat dot max, this current index answer, or previously if we got the maximum answer. Okay, and ultimately we will return this answer. It should work fine. Let us try to see. Okay, unknown error. Okay, let me see. Let me just connect. I got power off. Yeah, I guess I back. Let's see if we have any errors. I think there are so many problems related to this, and in many events, this type of questions generally get asked. So start time is not defined. I guess I typed spelling. Okay, I hope that was the one. And then it is like again line number 29. Start time of I. Okay. So yes, those are the mistakes. Let's see if it is working fine or not again. Again, there is an error. Current answer, okay, is equals to gap of I and gap of I plus 1. Gap array, right? So gap array is something what I have named. All right, no issues. Let us just update this gap array here as well. And I hope that should be fine now. Okay, this itself getting failed. Left array, left max, right max. Those are the names that I have given. So right max, and for this one it is like left max. Okay, I guess these are blunders, small blunders, but yes, definitely problems. Okay, again like occupied space. Damn, so many errors on same line. Occupied space, occupied space. Here also it got passed. Okay, let's try to submit also and see if it's working fine or not. And now if we discuss about the complexity, the first for loop is basically taking big of n time. Okay, the storage is basically like 3 times we are using the array, so 3 cross n is basically n. Now next is like the first for loop, again it is like running all the way till n. This next array is again running all the way till n. Okay, and in this particular for loop again we are running all the way to n, so 4 times of for loop is been run, so it is like 4 cross n. The answer is again n. So both the space and time complexities are approximately big O of n, big O of n. Okay, I guess you get the understanding of this particular solution. If so, please make sure to like this particular video, and thank you for watching this video. Bye bye.